Pankaj here. Today we're going to be doing a question from linear programming problem. Okay, we have already looked at a particular question wherein I explain the different terminologies involved in linear programming problem, or LPP. What I'm going to do right now is to take care of a question from the miscellaneous exercise of the NCERT textbook. Okay, well, the question is based on transportation, and this was one question which I found was a bit hard to solve, but nevertheless I continued to solve it, and I'm going to try showing that question to you now. Okay, so that's the question I am talking about. This is the 7th question in the miscellaneous exercise. What I'm going to do is to solve this question and explain to you how exactly we should be proceeding to solve a LPP, or a linear programming problem based on transportation. Okay, so if you can look at this question here, he's talking about an oil company. Well, the situations may vary. In this case, it's an oil company. Sometimes it might be some other company or a depot from where commodities has to be transferred or transported to a different location. Okay, so in this case we see that we have two depots, depot A and depot B. Okay, and from these two depots I'm supposed to be transporting oil. Okay, and the depots have a capacity of 7,000 and 4,000 liters as mentioned here, and the depot requirement, the requirement of the petrol pumps has been mentioned here as 4,500 and 3,000 and 3,500 liters. And what he also provides us is with a table which tells me what is the distance from A to B, or D to A, and then I have the distance mentioned from D to B and E to B again. Right, now this table is being provided to me. Apart from this, he gives me a very important information here. He says that the transportation cost of 10 liters of oil is 1 rupee per kilometer. Okay, now this is a tricky part of the question which needs to be taken care of. So I'm now going ahead and finding the minimum cost. So this is a minimizing type of question. Okay, now when we look at a question like this, okay, it's very important for us to make this kind of a graph. All right, always keep your depots to your left, okay, and to the right. So basically your depot will be at the left and the right, and your petrol pumps, or the place where you need to transport the commodity, will be in the middle. Generally what I have come across is two depots and 3 places where you need to transport the commodity. This is what I've come across. Now once you make this, okay, mention all the requirements here. So the requirements at D, E and F is 4,500 liters and 3,000 liters and 3,500 liters, and then I have 3,500 liters. Okay, now once you have made a note of that, please make a note of what is the capacity of A and B, which is 7,000 and 4,000 liters. Okay, wonderful. Now what is the distance from A to D? The distance from A to D is 7 kilometers. So I'm going to make a note of 7 kilometers under the line here. 7 kilometers. And here from A to E, the distance is 6 kilometers. Okay, and from A to F, and that is 3 kilometers. Okay, and now the distance from D to B, that's 3 kilometers. And then I have B to E as 4 kilometers. And then from B to F, that's 2 kilometers. Perfect. Now I've been provided with an information. What it says here is that if I'm transporting 10 liters for 1 kilometer, then I'll be charged 1 rupee. So for 1 liter, the transportation cost is simply going to be equal to 1 over 10 rupees. Correct? For 1 liter for 1 kilometer, and that's simply equal to 0.1 rupees. That is for transporting 1 liter of oil for 1 kilometer. Now, so if I'm now transporting, let's say, X liters of oil from A to D, when you start solving a transportation problem, first start with this line. Always fix this as X liters. Okay, I'm going to remove the liters from there. I'm just going to maintain X. So I'm going to be transporting X liters from A to D, and let's say I'm transporting Y liters from A to E. So always fix this as X and always fix this as Y. Okay, fine. So if you have transported X liters from A to D, the remaining liters of oil should come from B. So what is the remaining amount of oil, or the liters of oil that I need? 4,500 minus X. That's the remaining oil that you need from B, that needs to be satisfied from B. And if you are transporting Y liters of oil from A to E, the remaining, which is 3,000 minus Y, has to come from B. Okay, now let's see what is left out in A. If you have transported X here and Y here, what is left out here will be 7,000 minus of X plus Y, and you're going to be transporting all of that, 7,000 minus of X plus Y, and you're going to be transporting all of that to F. Now if you're transporting 7,000 minus of X plus Y to F, what is going to happen to the depot B? Now there are two ways of calculating what is going to be entered here on this line. Either you can say what is remaining, or what is that I require at F, which is going to be 3,500 minus of this entire entity, isn't it? Or you can either say that whatever is remaining here at B will be transported to F. In both the scenarios you will get the same result. Okay, now if in case I am doing 3,000 minus of 7,000 minus X plus Y, I will remain with the minus 3,500 minus 3,500 plus X plus Y. Okay, so 3,000 minus of 7,000 is minus 3,500, and this is going to become positive, and that's what's going to remain. If I'm going to do 4,000 minus of 3,000 minus 4,700, I will come up with the same value. Now this is the basic table that you made. Okay, this is the basic graph that you made. Now I'm going to be calculating the transportation cost. Okay, so what is the transportation cost from A to D? I need to know that every liter transported for 1 kilometer, the cost is 0.1. So in this case, I'm transporting it for 7 kilometers, and I'm transporting X liters of oil. So the transportation cost is going to be 0.7 X. In a similar fashion, I would be transporting Y liters of oil for 6 kilometers. So the transportation cost here is 0.6 Y. All right, and here the entire entity, that's the amount of liters of water that's being transported, will be multiplied by 0.3. So that's 0.3 into 7,000 minus of X plus Y. Okay, now what happens here? The transportation cost is simply going to be equal to 0.3 into 4,500 minus X. And what's the transportation cost here? The transportation cost here is 0.4 into 3000 minus y. And what about the transportation cost here? It's 0.2 into minus 3500 plus x plus y. Now that's my transportation cost. Okay, now this is a very complicated question, and that's exactly why you see a lot of numbers being mentioned here. It might look a bit complicated and a bit shabby. That's only because of my writing on the sheet. Okay, so when you write this on your book, please make sure that you write it in a neat way. Okay, perfect. So now what we're going to do is to frame our LPP. I have to transfer it from A to D, which means x cannot be 0. So x has to be greater than 0. And again, I have to be transporting from A to E, which means y has to be greater than 0. Okay, and also I have to transport from A to F, which cannot again be 0. So that's 7000 minus of x plus y has to be greater than 0. And the similar argument can be applied to this. So that has to be 4500 minus x has to be greater than 0. And again, 3000 minus y has to be greater than 0. And likewise, I will have minus 3500 plus x plus y has to be greater than 0. Alright, now with all this information, let me try to solve this. Okay, so these two equations are set. I can't simplify this further, but I'm going to work with this equation. This can be written as minus of x plus y has to be greater than minus 7000, which means x plus y has to be less than 7000. Correct? And here, this can be written as minus x is to be greater than minus 4500. That simply implies that x is less than 4500. And here minus y is greater than minus 3000, and that again implies that y is less than 3000. And I will have x plus y is greater than 3500. Now this is the equations that I formulated. I also need to find the objective function, isn't it? Now I will find the cost function here, or the objective function. Okay, objective function. Let's see. In a transportation problem, finding the objective function is a difficult task, but if you can focus yourself and solve the equation properly, you should be able to do that. Okay, so let's scroll up. So what's the cost of transportation from A to B? That is 0.7x. So I'm going to write 0.7x here. Don't worry about this. I'm writing about the picture itself. When I close this picture, my equations are going to be looking up straight. Okay. And what's the cost of transportation cost from A to E? That's 0.6y. And what about from A to F? The transportation cost is 0.3 into 7000 minus x plus y. Okay, plus, now from this side, what's the transportation cost here? The transportation cost is 0.3 into 4500 minus x, and again plus 0.4 into 3000 minus y, and then I have plus 0.2 into minus 3500 plus x plus y. Wonderful. Now that I have mentioned, let me just close this, and perfect. Okay, now I'm going to try and solve this for you. So this is going to be equal to, so what I have done here is to solve the objective function for you. Okay, I have gone ahead and simplified this. I have multiplied all these numbers, and I have simplified the objective function, which has given me the objective function as 0.3x plus 0.1y plus 3950. Okay, now let me frame my LPP. Okay, so I have made a few boxes here. Ideally for an LPP I had advised you to make 3 boxes. However, in this case I would need only 2 boxes. Okay, one is for the LPP and the other one is directly for the corner points. Otherwise we would have had another box, which is the first box which we make, identifying what is the commodity and what needs to be transported and stuff. Okay, so this is my LPP. What's the next job? To plot this on my graph line, right? Okay, let's go to the graph. Okay, now we already know what kind of a line this is. Now what I'm going to do here is to take the scale. I'm taking 1 unit on the x-axis, 1 unit on the x-axis as 1000. Okay, 1 unit is equal to 1000 liters. All right, and on the y-axis again 1 unit is equal to 1000 liters. This is x and this is for y. Many students don't do that, but it's actually important to mention the units. Okay, so when I go back and look at this, this is nothing but x plus y equal to 7000, right? So which can ideally be written as x by 7000 plus y by 7000 is equal to 1. All right, and what is this equation? This is nothing but the intercept form of a straight line, which means this is x by a and y by b is equal to 1, where a and b become the y and the x intercepts. Here both is 7000, so the straight line that I'm going to be drawing is going to be that to that. Okay, so that is the equation for, okay, I'm going to extend this line. Let me extend this line. Okay, now that is what? This is my x plus y is equal to 7000. Similarly, I have the next equation, which is x plus y equal to 3500. It's again, you know, x by 3500 plus y by 3500 equal to 1, which means the line will be cutting the x-axis and y-axis both at 3.5. So I'm going to draw a straight line going through 3.5 there. I'm going to just pull this up. X plus y equal to 3500, and that's the equation here. And what else? X is less than 4500, which means x is equal to 4500. In this case it's 4.5, so I'm going to draw a straight line here from 4.5. Pull it up all the way here, and that is my x is equal to 4500. And the next equation that I have is y equal to 3000. So that's the line, y is equal to 3000. Okay, let's get back here. So this is y is equal to 3000. Perfect. Now I need to now find the common area for all of these equations or inequalities. So at the first place I had x plus y is less than 7000. I substitute 0, 0, which is less than 7000, which means the half, which is having the origin as the origin in it, is going to be the region which has the solution. So it's going to be this way. The solution is to this half. Now the next equation which I had was greater than 3500. The origin does not satisfy the equation, and hence this half is the solution. Okay, next y is less than 3000, so this half is the solution. And then I have x is less than 4500, which means this half, or this side of the graph, is the solution. Now I'm now going to be finding out what is the common region for all of these graphs, and what I see is that the region here is the common region which is going to be satisfying all of these inequations. And once I identify this region, I now will proceed to find out what are my corner points. Alright, I'm going to be updating all of these on the graph and solving it, and then I'm going to come back to you. Okay, now what I have already done is to solve the objective function with all these corner points, and after solving you can certainly see that the value which is the least is here. So that's the minimum, and that's my values for x and y. What does that basically mean? That I should be transporting x 500 liters and 3000 liters for x and y. Okay, now if I can go back and look at the question here. Okay, let's see, what does it mean? It simply means that I have to transport 500 liters of oil from A to D. That's 500 from A to D, and from A to E I should be transporting 3000 liters of oil. And if I'm transporting 500 and 3000 here, which is 3500, which means the remaining oil should be transported to F, which is 3500. And what happens to this from B to D? X is 500, which means this is 4000 liters of oil from B to D, and from B to E is 0 because Y is 3000, which means I need to be transporting 0 liters of oil from B to E. And what happens to B to F? It's again 0 because 3000 plus 500 is 3500, so I need to be transporting 0 liters from. So what's now going to be my closing statement? My closing statement is going to be this. So it's actually a very simple question if you now think about it. What's the first criteria? The first criteria is to understand what is the question here and identify that this is a transportation problem. Now once you know that it's a transportation problem, you need to make this kind of a mapping or a graph. So always your depots will be on the left and the right hand side. The supply or the place where you need to be transporting the object or the commodity will be right in the middle. Make these arrows, write what you're transporting, and underneath that write down the kilometers. Sometimes it's the cost that you will be writing, and above that you will have your cost function, or what's the cost from transporting from A to D. And remaining things, you know how I proceeded. Always keep this as x, keep this as y, and keeping those two as x and y, formulate your other equations. And as I said, the major task is to find out your cost function. Okay, so finding the cost function is the greatest task, which you need to be very careful about. So once you know your cost function, okay, which is this, once you get your cost function, all you need to do is to graph it, get your LPP, graph it, get your corner points, and that should take care of the question. Okay, so thank you very much for watching this video. Again, subscribe to the channel. Ask your friends to watch these videos. If it is informative, it will certainly help the other students in understanding the transportation problem. Okay, and any suggestions or any kind of improvement that you feel that I should be making on the video, please mention it on the comment section. Thank you very much, and goodbye.